Hello everyone, I'm Rekha Murthy, Assistant Professor from Department of Electrical and Electronics Engineering. Today I'm here to explain the experiment related with the Electrical Machine Laboratory 1 of Cycle 2. The Cycle 2 experiments are the Scott connection with the balanced and unbalanced loads, separation of hysteresis and eddy current losses in a single phase transformer. So this completes the transformer part of the experiments. Then related with the alternator experiments here, that is voltage regulation of an alternator by EMF and MMF methods. And the fourth experiment will be the voltage regulation of an alternator by ZPF method. Now let us consider the experiment number 5, that is a Scott connection with a balanced and unbalanced resistive loads. So here, before we go with this experiment, we should know why do we connect this Scott connection. This is one of the method of transformation of the three-phase power from one voltage to another by using two transformers. So this scheme is widely used for like three-phase to two-phase and vice versa transformation. So in this arrangement, two transformers of the same rating are required. So one of the transformer is called as the main transformer, which must have a center taps, both primary and as well as a secondary. The other transformer known as a teaser transformer, which must have the primary and secondary windings. So here the number of turns which we are going to take up, it will be around 0.8666 times of the respective turns of the main transformer, where in the case of the teaser transformer. So in the case of teaser transformer at the primary side, we should take a 86.6% of the tapping. So here one end of both the primary and the secondary of a teaser transformer will be connected to the center tap on the primary and secondary of the main transformer respectively. And the two ends of the main transformer and 86.6% tapping on a teaser transformer will be connected to the three-phase supply on the primary circuit and to the load onto the secondary side. We have to make sure the current ratings of the two transformers should be same. Okay, so by this above arrangement, we can get the two single phase supply. This is how we are going to perform the Scott connection. So where you can obtain the two single phase from the arrangement of a three phase. Okay, so the main aim of this experiment will be to convert a three-phase system to two independent single-phase systems by using a two single-phase transformer and to study their performance. Okay, so what we have to do is we need to individually study those two transformers which you are going to utilize it to obtain the two single-phase output. Okay, now let us see what are the apparatus do we require to conduct this experiment. Obviously, you require the single phase transformer which will be of a same rating. So here we are going to prefer the 2 kVA transformer with the 86.6% tapping on the primary, and also the another will be with the 50% of a tapping on the primary side. In addition to that, we require we need to find out its performance, means we are going to find out the efficiency. Okay, so for that definitely we require the parameter like voltage and current. So we have to also we should need wattmeter also, because the efficiency will be the output power by the input power. So definitely we require one wattmeter. So which wattmeter you are going to use? Here, since we are, it depends upon to the load, what load you are applying. Since here we are applying the resistive load bank. Okay, since on the secondary side we are using resistive load bank, that means we need to take the which kind of wattmeter? We require the UPF wattmeter. Okay, so we require the UPF wattmeter. Since we are using two transformer, definitely we require the two UPF wattmeters. Okay, and in addition to that, we also want the ammeter and voltmeter. We require a 2 ammeter and 2 voltmeter, which is of the range of the ammeter of the range of 10 amps and voltmeter with a range of 0 to 300 volt. In addition to that, one more we require one more thing, that is nothing but the one more voltmeter. Okay, so in that voltmeter will be having a 0 to 600 volts. We require that one to measure it across the supply side. Okay, and resistive bank load which you are using, also we will prefer it around the 10 ampere resistive load bank. So we require the 2 resistive load. So everywhere you will see that since we are using a 2 transformer, we require the 2 wattmeter, we require a 2 resistive load bank, as well the wattmeter and voltmeter. Okay, now let us see what will be the circuit diagram. This is what the circuit diagram, where as I told you, we are going to make use of, first you need to draw, not at the beginning, first you need to draw the teaser transformer. How does the teaser transformer looks like? It will be having a terminals P1 and, okay, so wherein here you have to consider that 86.6% tapping of the first transformer. This is a teaser transformer. This is the main transformer. So 86.6% of it, the 50% directly you should give it off. That is, from the primary of this 86.6% need to be given to the 50% of the tapping of the main transformer. Okay, this is how we have to divide it. Now the remaining, this is about the primary side. Now how to do the remaining all connections? It is very simple. From the one end of this, we have connected this second part of the connection. Now go with the teaser transformer. The first part of a transform, the first end of this should be given to the ammeter, which will be always in series, and the ammeter we have to prefer the 0 to 10 amperes. So here since here the other end of the ammeter need to be connected to the L, and the MC should be shorted, and M, it is main, which should be connected to the one of the supply end. So that is nothing but the 3-phase. So this will we are going to make use of a 3-phase supply, right, at the beginning. So we are converting 3-phase to the 2 single phase output, right? So input will be your 3-phase. So that is why M should be connected to the one of the R connection of the 3-phase supply. Where you need to connect it, that is to the output of the auto transformer. Right, fine. Then next, similarly we'll be having here R and Y connection. So Y output of an auto transformer, that should be connected to the series with the ammeter. The other end of the ammeter should be connected back to the one end of the primary, that is primary end of the main transformer, where the VV, that which you are going to prefer the voltage VV of around 600. So that should be shorted to each other. Okay, the second wattmeter. So now we have stuck with the only the end of this wattmeter. Now we have to complete the loop, right? So how to complete that? Again, we need to take up the other end of this P1 transformer, as how you did a connection here. Similar way we have to connect it here. So P1 end of this should be connected to the ammeter. The other end of the ammeter will be connected to the L of one of the second wattmeter, and the M should be connected back to the that is the input, that is the output of your auto transformer, that is B phase. Then MC will be shorted. As well, this is completes the primary side. This is how first you have to start to write the representation of the 86.6% of a transformer and the main transformer. The whatever the left end is that you need to connect it in series with the ammeter. Everywhere you will see the beginning of this itself is connected to ammeter. Here also you can see a beginning of this, it should be connected to ammeter, and as well the other side which is let out is also been connected to the ammeter. Later on you have to complete the loop by connecting the two wattmeters. So it is very simple connection. Coming to the secondary side, on the secondary side, the one end of the secondary winding should be connected to the ammeter, which is in series with the resistive bank load, and coming back, the other end of the resistive bank load is closing the loop to the secondary end of the winding. The same thing we need to follow it up for the other transformer. Okay, the last what you need to do is we need to connect the voltmeter across the each part, that is this is across the supply R and Y, and that is to observe how much the three-phase supply is coming, is going getting fed into it, and how much the two-phase supply you are going to obtain. Okay, so V1 is obtaining at the one across the load bank. The events V2 will be appearing across the second load bank. Now you can see that where we are going to conduct this experiment. So in our laboratory, we are going to conduct the experiment on this panel board. So where we have already marked, we'll be using this 2 kVA transformer. So similar rating you have to take. This two are the 2 kVA transformer, and the last one is a 1 kVA. Okay, sorry, all are 2 kVA itself. So we will choose the any of the two transformers. So we are going to make use of first transformer, that is teaser transformer is this one, and the main transformer I'm using it as this one. Okay, and as well there will be a provision of the meters. This will be the 2 watt meters where I have done already M and C connection is been shorted together. These are the 2 watt meters with a range of 10 amperes. I have set it to 10 amperes, and 600 volts we have to utilize it while doing the connection. Then here this is the voltmeter which we have provided, and this will be the additional ammeter because we require IR measurement, IY measurement, IB measurement. Also we have connected, this is about the primary side. On the secondary side also we require the 2 ammeters. So this will be the I1 for the first secondary part of the circuit. Second secondary part of the circuit will be the I2, which I'm going to use here, the ammeter. Okay, and we require the 3-phase input right to these terminals. So we require the 3-phase auto transformer. This is what the auto transformer 3-phase input, which will be directly given to these RYB terminals, and output of this need to be connected to the rest part of the circuit. And these are the 2 resistive bank loads of a 10 amperes. We are going to use it. Okay, so each switch will be of a 1 amperes. Right, so it constitutes 10 amperes of a load. Now let us see that how exactly the connections will proceed. So this is what as the input RYB is given to the input of an auto transformer. The output of this has been connected to the M connection of one of the wattmeter, and the L of the same wattmeter should be connected to an ammeter. The other end of the ammeter need to be connected to the P1. So here you can all of you just concentrate. Here I have taken a P1 as a this position. So this will be, I'm going to consider it as a P1, and the above one will be the P2. Okay, so this will be considered as a P1. This above one means we have to take a 86.6%, right? So that tapping we need to select. So this will be the P1, the below the suffix will be the P1, the above will be the P2. Right, fine. So you can make a note of it. So on the circuit diagram, so this will be the P1 I'm going to use, the above one will be the P2. Similarly for the second transformer also the same will be applicable. And where will be the secondary? Secondary also will be the down one will be, I'm going to consider as a S1. The above terminal will be, that is 230, that will be considered as a S2. Okay, next part of this circuit. So here I have connected 86.6% of a tapping teaser transformer to the 50% of the main transformer. Then what I have done, taken the Y connection I have connected to the ammeter. The other end of the ammeter need to be connected to the P2. So can you all see that? Again I have taken P2 as a above one. Okay, so this we have to take almost that 440 volts itself. Okay, now next what you have to do is the other end of this P1, P2, where the P2 is been connected, the shorted end need to be connected to the VV connection. So that VV which you are going to use for from the both of the wattmeter is 300, which I have to connect it the other here this side, which I am not able to show it here. It will become more clumsy. So I have to make it more clear. So I have taken the connection here, but actually this connection will be done from here to the other knob. Okay, so this is only for your simplification. I have done this connection. Actually you need not to connect here, but actually we need to connect it to the one of the terminal of the wattmeter V connection to the other V connection. Okay, so where the same thing which will be replicated on the other side of the meters. So VV connection we have done. Then next the shorted end itself we need to connect it to the P2. Next coming to the B phase. B is connected to M. The other end of this should be connected to the ammeter. The other end of the ammeter need to be connected back to the P1. P1 of your main transformer. Okay, next coming to the next part of it, we have to complete the secondary loop. So this completes your the primary side. Now coming to the secondary loop, this will be considered as your S1. S1 is connected to the ammeter. The other end of the ammeter need to be connected to the resistive bank. The other end of the resistive bank need to be connected to the S2. This is what completes the first transformer secondary loop. Second transformer secondary loop we are going to complete in the similar way. So all of you can observe that the ammeter which I am going to select here is this one. Okay, now you can see that this is what S1 is connected to ammeter. The other end of ammeter should be connected to resistive bank. The other end of the resistive bank is connected back to the S2. So this completes the secondary of the secondary transformer loop. And similarly, what you have to do, now we need to insert the voltmeter. Insert the voltmeter on the primary side to observe how much the three phase you are going to supply, and also we need to see that the voltmeter should be inserted on the secondary side also. How much the two phase supply you are going, how much you are going to get the two phase supplies. So this is what the voltmeter connection, okay, which has been connected here. And similarly, this is another voltmeter. Similarly, you can see this will be the another voltmeter which has been connected. So this completes the connection part of a circuit. Now we can go with the procedure. So coming to the procedure, the connection will be made as shown in this figure, what we had done here. And with the auto transformer, this will be in the minimum position. So we need to apply the three-phase supply. The three-phase supply is switched on and the auto transformer is now operated, and a line-to-line voltage of around 400 volts is been applied to the primary of the Scott connected transformer. So you can see here that the voltmeter which is connected here, we need to see it is appearing 400 volts or not. Then the no load readings are to be taken down. Okay, then also what will happen here, the load is in off position. Now the secondaries are now, it has been loaded equally in steps of about 2 amperes, and each step the readings of all the meters need to be taken down. And the loads on the secondaries, now what you have to do, we need to apply equally. If you are applying 2 ampere here also we need to apply 2 ampere. Again, if you apply here 4 amperes means here also 4 amperes. So that is for the equal load. Okay, if it is for the unequal load means we need to keep the one load as a constant to some value, let us say 4 amperes, then another need to be changed frequently, and for the each steps we have to take down the readings. So like that we need to observe for all the equal load as well as the unequal loads. Okay, finally you should not directly switch off the supply. We need to remove the loads on the secondaries, and here again we need to bring back to the zero off position. Then we need to minimize that auto transformer to a 0. Okay, which we had used a 3-phase auto transformer, bring it to 0 position, then you have to switch off the supply. So this is what the procedure we need to follow to conduct this experiment. Now coming to the tabular calculate column what all the values you have to take on. So these are all the things which you have to observe. IR, IY, IB and W1 and W2 constants need to be taken down. So that we have already observed in the cycle 1 session. So okay, so how to calculate the K constant, respectively K constant need to be multiplied, which has to be followed here. Then I1 and I2 is indicating about the how much load you are going to apply, 0 ampere, 2 amperes, like that. So this is first thing is your equal loads. The second part of it is your unequal load. You can observe here. So here it will be a constant. The other side it will be keep varying. Then you can note on the V1 and V2. Okay. Now here, now coming to the calculation part, after taking down the readings, we need to just find out the efficiency of both of the transformer. We have to find out. Okay, for each of the readings we need to find out. So efficiency formula is V1, that is almost you know that output power divided by input power. So what is that in the output side? Have you connected any wattmeter on the output side? No, we have connected the voltmeter and ammeter. So the product of the voltage into current itself will give you the watts, right? So V1 into I1 plus V2 into I2. So divided by the W1 plus W2. Okay, multiply with 100. So this is what we can get the efficiency from for the each of the cases. Okay, so similarly we need to find out the also we have to find out the output in watts. Okay, so the output in watts can be calculated by nothing but it is a product of the V1 into I1 plus V2 into I2. So this separately we need to calculate it, which you can see it here. Okay, here along with the efficiency also you can calculate the output in kilowatt. That is V1 into I1 plus V2 into I2. Okay, so the value which you will get for the efficiency, the respective output there in the watts need to be plotted as a graph. So the y-axis will be the efficiency and the x-axis will be the output in watts. For the each reading we have to take down. Okay, for both equal loads and unequal loads. So from this what observation you can see that the efficiency will be very high with the case of the equal loads, because there only you are increasing the load proportionally, right, for on the both the sides. So definitely the efficiency will keep increasing. Comparatively, if you consider for your unequal loads, so it is quite less. So this is what completes the experiment related with the Scott connection. Coming to the result, so a three-phase system is converted into a two independent single-phase system by using a two single-phase transformer, and the performance has been studied with the balanced and unbalanced resistive loads. So thank you for watching this video.